Hi, I'm Alan Ross. I'm here at the IEEE PES T&D, that's a lot of acronyms, conference. This is the 2020 version that is actually being held in 2022. These interviews that we're conducting is with thought leaders on the future of the power industry. So enjoy. My next guest is Mike Edmonds from S&C. Mike, it's good to have you join us. Thank you very much.
Thank you.
So, Mike, we're talking about the future and what is not, because it's becoming, challenges, opportunities, problems, you name it.
Right.
We're at a pivotal point in power generation and power everything. So when you look at the power industry, which you guys have been involved in for a long, long time,
Right.
What do you see as the major challenges facing us?
Well, it's actually the energy transition, literally the transition. So where generation's happening and moving to the distribution grid is becoming the backbone of the grid.
Yeah.
So the technology needed and how you modernize the distribution, which is where the consumers are heading up. You think of the pandemic, everyone's now working from home, or most of us. Electric vehicles are going to be plugged into the distribution grid. So a lot of changes are happening.
Well, okay, now, change is good if we control it. Change is bad
if we don't.
Well, yeah, so what are the things that we need to control, given the fact that a lot of action takes place at the distribution?
Oh, that's a great question.
Okay.
So there's not very much automation in distribution. So we don't have a lot of segmentation, and we have a large number of customers. We still have things called fuses that, if they operate, can take hours or days to fix. So just think about that automation it exists in the transmission grid, doesn't really exist in the distribution grid right now.
Right.
So how does that look? How do you get the data back? How do you make decisions of switching and protection? So some of those are things that we've been really seeing from an S&C standpoint. And think of it as the lateral protection or the single phase. So think from the customer going back up the grid as they go from the customer transformer, whether they got a URD, how they go up to the laterals. How do you get those systems to be on as much as they possibly can? And that's been one of the revolutions we've been seeing driven, and we see that intensity increasing.
So you mentioned data acquisition, everybody's talking about data. Now they move from, data to we're AI, right? And I have not really seen effective AI in our industry, right? They talk about it, and some people take machine learning to be AI. It is not, it's just machine learning. So what do you see the complexities of this massive amount of, everybody here, I mean, at this T&D conference has got a monitor and say, buy my thing that'll send you data. We're going to be awash in data. What are going to be the problems as we see more and more data we probably have good acquisition. Do we have good analysis? Do we know where the data should be housed? Do we make sure that your thing can talk to my thing because I am one thing? Talk about the complexities of data.
Well, the interoperability, how do they work together? That's one of the big challenges. I think if you think about where decisions have to be made in the time horizon, so do you have time to take data, analyze it in a central location, look for patterns and then make decisions? Yes, you do have time, but if you've got no power for 20 minutes, you don't have time. So think about where decisions have to be made in the grid, which means data acquisition, analysis and decision needs to be done closer to the problem.
Built into the system, so the data helps make its own determination. You can act on it. That's excellent.
So you do that. You do those switching quickly right away. Later on, you can do some other topology changes. So really, how do you recover quickly? A
part of this whole happening at the distribution level is electrification of transportation. Everybody has their take on it. Forget how long it's going to take to get there. Let's just assume we're going to get there, right? Even if we get to 30% EV adoption in the United States, that is a potentially doubling of the demand on the grid, right? 30% adoption. And it may be more than 30% because the next generation thinks we're the last generation to buy these automobiles that run on what?
Gasoline or something else, right? That's right.
You use dinosaur? Yeah, that's right. But what is the electrification of transportation, this massive growth of EVs, what's that going to do to the grid?
It's going to change the edge of the grid. Suddenly the charging and the demands are going to go up. Yes, I'm very sure houses and our homes are going to become more efficient. That's happening naturally, right?
Right.
But that's not necessarily going to replace the demands of electric vehicles and charging. So it's going to change the configuration of the distribution grid, in our opinion. And actually, how do you get power and keep power there? So let's measure the lack of power. When we have metrics called SAIDI that exclude storm days,
Yeah.
you're not getting an honest assessment of where the power's not available. No power for 6 days is not counted in SAIDI. So I think one of the things that's going to happen for our industry is as electrification comes to bear, when consumers notice they don't have power for days and can't charge their cars, questions will be asked, are we measuring the grid correctly?
Yeah. So, do they not, weather events, are fires considered weather events? They don't count as SAIDI problems?
It depends what jurisdiction you're in, but I suspect if it's a named storm.
It's a named fire. Because now we have named fires,
Yeah.
the alcohol fire and this fire and that fire. It's a crazy thing.
Yeah.
Yeah. One of the things that's also challenging the grid is the fact that a lot of data centers are moving back onshore. They're for cybersecurity and
Right.
other reasons. I know there's some sexy things where, like Microsoft has an island that floats and it's a data center, right? That's an anomaly. That is not the way it's working. So there's a lot, whether that's colo data centers, whether that's company data centers, whatever it is, data centers need clean power.
Yes.
They can't build everything through redundancy, because dirty power, you can't just make redundant. It's going to be dirty, dirty, dirty. I'm a reliability guy. We believe in 5.9 reliability, or else airplanes fall out of the sky.
Right.
So the data world has said, hey, let's be reliable by 5.9s by having 3 generators. Well, if they're all 98, 96, 97, you're not 99%.
Right.
Take any one of them out, which is happening, because now they're saying you got to do more with less. Now you begin to affect that whole operation. Data centers coming onshore, Bitcoin mining not happening in China, now happening here and taking up an enormous amount of power. Yeah. All of these things are they're like the perfect storm, if you will. Some people say that we have enough generating capacity to get us to the next level, we're just not using it. But if we use it, we are stressing out 20, 30, 40-year-old assets beyond what they should be stressed out to. So it looks okay that the capacity is there, but not if you run it at that capacity for long. So there are a lot of things that are coming to bear on this thing. What is S&C doing to be able to look at the future and be where the puck is going to be, not where the puck is today?
Yeah, one of the things we're very clear about is distributed intelligence. How do you actually get, I mentioned greater segmentation, how do you make sure the power stays on so a momentary fault doesn't become a permanent outage? So keeping that infrastructure together. So, and that's where we spend a lot of our time. So, you'll see some of our results in Florida in storms where the grid automatically reheals really quickly once a problem happens on the line. So again, it's making sure power can be rerouted around problems, making sure a temporary outage doesn't become a permanent outage, and then making sure there's enough segmentation in the grid. So think about more and more of intelligent switches, understanding when to retest the line, put the line back on. And that's really what we've seen is, I describe it as blue ocean. And if you look at what S&C can do, we're creating now as a first mover this whole lateral protection market where there are different ways of taking that last mile, that backbone from the feeder through to the customer. And how do you change that topology? And you'll see us doing it now, and we'll have some more developments in the future as you continue to revolutionize that part of the grid. Because if it doesn't matter, if you don't got power, it's not going to work.
That's right. You said reheal itself?
Reheal, yes.
I love that. I haven't heard that term before. But a self-healing grid.
Yep, so we have the ability to have switches talk to each other and not have to go through a centralized system.
Okay.
And they all know where they have spare capacity. And if there is a problem, they can make logical decisions in real time to open or close or reheal the grid to reroute the power.
That's exciting. That's really good. You all have been part of IEEE for a long time. You personally have.
Yes.
What's your history with IEEE?
Oh, I've been a member of IEEE in the UK, you can tell by my English accent, before I moved to the States, a member of the IEEE. We actually, my team are participants of the local PES Society in Chicago. We've always been part of the IEEE as a company. In fact, if you go back to pre-internet days, S&C used to launch.
I lived there, by the way. I know pre-internet.
I didn't like to assume that. I did as well. This IEEE has always been the place to release new products.
Yeah.
And that's what SNC's done. In fact, look at our history board. You can look back to the 1950s as our participation in the IEEE. And today, we actually have another new product launched at IEEE.
Yeah.
So for us, it's been a really important part of the industry, our membership of it, our participation in it.
Do you have engineers that are on the committees and on standards and developing and helping? Why is it valuable for them to do that? Because people say, well, you let people go away for a week, transformer committee. You know, I've got a friend that serves on the transfer committee. He goes away for 2 weeks on the not on vacation time.
Yeah,
and he would take vacation time. It's that important to him. But the company supports him doing that. So why is it valuable to the company to let people come and participate on committees and do volunteer work?
It's important because you get multiple views to the customer's problem. We can't assume as one company we know the answers to everything. And I don't think any other company can either. So the community of engineers looking at how they look at customers' problems, how they can address them, that makes it really important to find a solution that can be used across the industry. So that's why we've always been participants in IEEE.
That's excellent. That's excellent. Thank you so much. We have a Grid Edge conference that we're going to be doing in April. I'm on that steering, so this is a bold plug for it. I'm on that steering committee. SNC needs to be there.
With Grid Edge, but totally agree.
One of the things that we're struggling with as a society, PES, we created smart grid, right? And a lot of what you allude to is the smart grid part, right? It was created by 13 other societies in PES. Do you know how many other societies are still involved in them?
I do not.
Maybe one or two.
Oh, wow.
Which is a crying shame. And that's part of, smart grid has become, it's not that big of a deal anymore. But smart grid is really grid modernization. And a lot of what you're talking about is grid modernization, correct?
Yeah. Resiliency, reliability, how you actually act. And the grid of that last mile has to change.
Yeah.
It really has to change.
The grid at that last mile has to change. Yeah. And the grid has to heal itself.
Yeah.
Oh, I love that. Say it again.
It has to change. The grid of the last mile has to change.
Yeah, you said it twice, and I said it for you, but that was brilliant. Thank you so much. Anyway.
Good. Thank you for your time. I enjoyed it.
Okay, appreciate it, Mike.
Thanks.